Hi guys, my name is Ian, and this week I'm back with my solution to Paul McWhorter's Arduino with Python lesson number 17. This week the homework was to control the bats and make them actually hit the ball, so we're thinking about collision detection and stuff like that. It was all Python work this week. The Arduino code and hardware is unchanged from last week. So with that, let's have a quick look at said hardware. So here you can see we've got the nano, the LEDs, the piezo buzzer. Things are working as normal. The joystick is still there, you can move things, and there's a button to change the active bat, all like last week, so no change here. Let's look at the Python code where there has been changes. So, where have the changes been? Well, there was a slight change in the draw bat. I've had to add in a bit of extra information. I didn't need this last week, but I certainly needed it this week. And basically what that is when the bat is moved, the position's updated. Yes, certainly the bat's moved on the screen. But we need to also update these bounds so that I can check where the bat is. Okay. Next thing that's changed is I can now change the size of the bat. That's part of the game. When you actually successfully hit the ball, the bat is made a little bit smaller. Now let's go into the game, and on our way we're passing a few messages. These messages are basically the game end messages, of course. The thing is, they are always on the screen. It just so happens that until they're needed, their opacity is 0. So I draw them here and just set the opacity to 0. Later on in the game, the opacity is changed to 1. So let's think about the game. Now the game has a beginning, a play, and then an end, and then we want to play it again. So the way I've done that is having a loop within a loop. So imagine this. The while loop we've always had. While true, when is true? True, it's always true. Anyway, last week the while true loop was about collecting the Arduino data, moving the ball, moving the bats, etc. This week the while true is about setting up the game to be played. Then last week's loop is now the inner loop, and we've now got it as a not game over. There's a game over variable to control the inner loop, and of course we set it to be false here. The game isn't over, it's just beginning. So while the game is not over, we play the game. When the game is over, this variable will be set inside this while loop. Therefore this while loop will finish and we will fall out. We will wait to play the game again, and then before we play it again we do a bit of tidying up. We turn off those messages that we've been switched on. We reset the bat sizes, the bat color, the bat position. We reset the ball, and we flush the serial buffer. That turned out to be very important, and we'll come to that again later on. Anyway, let's have a look at this while not game over loop. Very similar to last week, not a lot of change in it, but let's have a look at some changes which are very important, right? One change is very subtle and is important, lest you get this bug. This piece of code here was basically creating a substitute checksum for the data if the data itself didn't come with one. What I neglected to do was make sure that that substitute checksum was created as a string, just like what it would be had it actually been received from the Arduino. Important here, because if that checksum happens to be being used and you're doing an is digit on it, an integer doesn't have that method, so you basically crash the code. A string has that method, so this should be a string. why did we get some data without a checksum? I hear you ask. Yes, when I hit this bug I wondered too. So all I could surmise is that while I was sitting waiting at the play again, well, as it happened, I had played the game once and went sitting waiting at the play again prompt, which you can see down here, because the game is sitting waiting to play again at the minute in the background. Well, I went and got myself a drink, and when I come back and pressed the return key, I got the crash. Now what I suspect had happened was that the serial receive buffer had continued to receive data. I mean, the port is open, still open at the moment, while the game is sort of in this pause, continued to receive data, and I think it just filled the buffer up. So when then I come round to look at the buffer, it was full of stuff that didn't make much sense. Overflowed buffers, probably not very pretty. So that is why in the outer loop, wrong one, in the outer loop, I flush the buffer. Okay, and that emulates what you would expect if you were actually entering the first while loop for the first time, having just turned on the serial port. Anyway, let's carry on with the code. And we were talking about collision detection. Well, how do we detect collisions? Well, actually we don't detect collisions at all. In fact, what we're doing is when the ball is about to leave zone 1 or zone 4, so that's the front, we have got to detect that. And the way you do it is, as I found, quite simply. We just look at the Z position, the Z axis. If the Z axis is greater, the Z coordinate is greater than the edge Z limit of the zone 1, then you're leaving zone 1. Similar for zone 5. So all we do is check is the ball essentially closer to the screen of the computer than the front of the box it's leaving. If so, we set a variable to be true, and that's just basically telling the code down below that the ball is about to leave the arena. The rest of the code is the same as last week's. This is all the edge detection to work out where the ball is within the arena. And then we've got the same code here which works out, well, where is the ball going to, because you know the ball from this code could be in two places because the ball has a size, and it could, the front could be in one zone and the back could be in another. This works out where the ball is going dependent upon the change in the coordinates for the ball's travel, and it's checking whichever coordinate is applicable depending on the direction, and which is related to how the various zones are positioned relative to each other. Anyway, imagine we have got a ball and we have detected it's in zone 0. Well, then what we've got to do is decide whether it's going to actually leave or the bat is going to hit it and push it back into the arena. Now, how do we do that? Well, quite simply, the ball has X and Y coordinates and the bat has X and Y limits, as in the ball's X and Y coordinates are essentially points, whereas the bat's bounds it's a bat with a left and a right and a top and a bottom. So all we have to do is check that the ball's position is within the bounds of the bat, both X and Y, and if it is, then we have a hit, and we up the increment the hit counter. We print hit down below just because it's why not. And then this is where we have the difficulty factor of the game. If you do manage to hit the ball, your bat's made a bit smaller, and with a smaller bat we have to redo a few things. We have to change the scalar which is used in the how the bat is moved, and we have to actually change the size of the bat. So that's calling that function we highlighted earlier. On the other hand, if the ball is outside the bounds of the bat, the active bat, I should point out as well, it's not bat 1 or bat 2, it's the active bat, which is set by this code here. So if the ball is outside of that, it's called a miss. The game over flag is set. That will cause it to drop out of this inner while loop. We also turn on these messages to, the game over message and the press return to play again. You shall see that in a moment. And we change the ball color to red. Now, assuming the game isn't over, we just carry on with the same ball direction reversing code as before. So in fact, what that actually means is, when you think about it, the bat is not bouncing the ball back at all. The bat just happens to be allowing the natural and visible wall of the arena to bounce it back, but that's just a subtlety. Anyway, assuming that we do have a ball and it's in play, we do things with the serial. We're sending stuff back to the Arduino. We're updating the beeps and the LEDs, and the only difference in this code is we've got this taken into account now, where if the game is over, it turns all the LEDs off and sends a longer beep as it happens. The rest of it's the same. And there we go, that's the code. So let's have a quick look at the arena. So there we go, that's if the game is over. If we show you the picture of it in play, that's what it looks like. And if we actually go to a demo of it playing, that is the game sitting waiting for me to press return to play again. So if I get that up so that I can see it also, then what we'll do is I will press return and we will see the game in action. So the ball is bouncing around and I need to be probably over in the second side, so I can move. Oh no, it's way back there. This game is fairly playable. If you do miss the ball and it restarts, the game's restarted, the ball will have a different random change vector, so you never get the same game twice. And sometimes, like in this one, some of the angles and some of the axes are a wee bit slight, so it can take a while for the ball to come up, and this one is going to come up. I don't know where it's going to go actually. I'm not very good at my own game. Oh, did I hit it? I think it did. No, I missed. Oh dear. I'm not very good at this game. Anyway, that's my solution. I hope you enjoy the code. Any questions down below? Any comments, likes? Thank you very much. The code, as usual, will be over on GitHub. And until next week, have a great day.